Hello friends, we are back with our new video. In this video, I will discuss how to create a nice scatter plot in R or R Studio that you can use for your official presentation or in your publication. Please visit our website statswithR.com for more details, and if you have any queries, shoot us an email at learnstatisticswithr@gmail.com. The overall process involves several steps and I will discuss stepwise. So let's begin. For demonstration, we use the dataset Graduate Admissions from Kaggle. This is a highly voted dataset. We download the data as a CSV file. The dataset consists of several variables. Here we focus mainly on two of them, the scores in TOEFL and GRE. As many of you might know, the scores in GRE are between 260 and 340, and in TOEFL they are between 0 and 120. This dataset contains observations from 400 students. To read the data in R, we use the following code. Let's see step by step. To read the CSV file, we use the function read_CSV, which is available in the package readr. So first we install this package and call into R using the command library. Once we run the second line, the data is read into the data frame GRE TOEFL data. The data frame contains 9 variables. We just extract 2 of them, namely the GRE score and TOEFL score, and store them into the vectors GRE and TOEFL respectively. Okay, once we run the code, the vectors GRE and TOEFL are ready to use. We want to create a scatter plot where we plot the TOEFL scores along the x-axis and GRE scores along the y-axis. Before we move to create the ggplots, first we need the package ggplot2. So we need to install it and call it into R or R Studio. For this, we use the commands install.packages and library, similar to the package readr. Now we are ready to create the ggplot. In the console window, type ggplot a blank bracket plus geom point within aesthetics x equals to TOEFL and y equals to GRE. And outside aesthetics, we set the size equals to 2. The default size is 1.5, and thus setting the size equals to 2 increases the size of the points. Now press enter. Okay, you get your first scatter plot. We can see that the axis titles are just the names of the vectors. For making this figure a presentation quality one, let's make some changes. First, let's rename the axis titles by TOEFL score and GRE score respectively, as this makes the plot clearer to your audience. To do that, add the line xlab TOEFL score within quotes plus ylab GRE score within quotes. Now press enter. Okay, you get your second scatter plot. You can see that the axis titles have changed. Next, you might be interested to add a title, say TOEFL versus GRE. To do that, add the line ggtitle TOEFL versus GRE within quotes. Now press enter. Okay, you get your third scatter plot. You can see that the plot title is created now. Next, you might want to move the title to the center. To do that, add the line theme plot.title equals to element underscore text h just equals to 0.5. Now press enter. Okay, you get your fourth scatter plot. You can see that the plot title has moved to the center now. Next, note that the axis titles and the plot title are quite small. When you use this figure in your paper, it may be just a 2" by 2" image, and then these titles will no more be readable. To enlarge them, add the line theme axis.text equals to element text size equals to 15. This increases the font of the axis. Axis.title equals to element text size equals to 15. This increases the font of the axis titles. And plot.title equals to element text size equals to 15. This increases the font of the plot title. If you don't need one or two of them, you can remove those lines. The larger the size you want, you need to fix a larger number. So choose a number accordingly. Now press enter. Okay, you have the fifth scatter plot with enlarged axis, axis titles and plot title. Next, we often want to overlay a regression line over the scatter plot. This line helps to have an idea about the average GRE score corresponding to an input TOEFL score. If you think you don't need this, you can skip the following steps. Otherwise, let's move on. Okay, we use the following code for adding a smooth regression line. Let's see step by step. First, we create a data frame from the vectors. We call it final.data. We need this for the subsequent steps as well. Next, within the function ggplot, we set data equals to final.data, and within aesthetics, we set x equals to TOEFL and y equals to GRE, similar to what we set within geom_point earlier. Note that similar code could be used to create the ggplot so far, but we wanted to skip the data frame. Next, within geom_point, we just need to set the size of the points. As we have already set the aesthetics within the function ggplot, we don't need to set them again within geom_point. We need to add the line geom_smooth a blank bracket. Now press enter. Okay, we have the sixth scatter plot. We can see that a locally weighted regression line along with pointwise 95% confidence intervals of the mean profile are overlaid on the scatter plot. Locally weighted regression is the default choice in the function geom_smooth. While you do not specify any argument within geom_smooth, you see a warning message geom_smooth using method equals to lowes and formula y tilde x. Next, you may be interested to fit a simple linear regression instead of lowes. To do that, add the argument method equals to lm within geom_smooth. Now press enter. Okay, we have the seventh scatter plot. We can see that the locally weighted regression line is replaced by a simple linear regression line. Now you might want to remove the confidence band. To do that, add the argument SE equals to false within geom_smooth. Now press enter. Okay, we have the eighth scatter plot. We can see that the confidence bands have disappeared. If you want to keep the bands, you can skip this step. Next, for this data, a simple linear regression appears to be a reasonable model. Although in general, this is not true and you might need to fit a higher order polynomial of the predictor variable. Say we want to fit a polynomial of degree 3. To allow that, we add the argument formula equals to y tilde poly x, 3 within geom_smooth. Now press enter. Okay, we have the ninth scatter plot. Further, we might want to replace the linear regression model by a generalized additive model or GAM. where the response is modeled as an unknown smooth function of the predictor variable. The discussion on generalized additive models is out of the scope of today's discussion. To fit a generalized additive model, we need the package mggcv. So install this from cran and call it into R using the command library. Here we just illustrate the default choice of the function gam. For more details, please check the package mggcv. To fit the default gam within the function geomsmooth, change the method from lm to gam and set formula equals to y tilde s within bracket x. S will be estimated automatically. Now press enter. Okay, we have the final scatter plot. You might consider this scatter plot for your presentation or in your publication. Sometimes we also have access to some extra information. For example, in the dataset graduate admissions, we have information about the university rating as well, which varies between 1 and 5. You might be interested to incorporate that extra information into your scatter plot. To learn that, watch our video how to create a factor-dependent scatter plot in R using ggplot2. If you found this video helpful, please like, comment, share and subscribe to my channel and press on the bell icon for more updates.